Yes, ma'am, visible.
Yes. So thank you, sir. So here I'm just going to have a discussion on the artificial neural networks in decision making. The artificial neural networks or the decision making, either of the two are not very new thing, but eventually in this present scenario, they are actually made as the great boom words of the digital era. So I like to just go on with the content of what we are just going to have a discussion for this 1 hour. So I'm just going to give you an overview of machine learning and a very brief and concise introduction to artificial neural networks and what are the theoretical developments of it, and of course the real life applications of ANN. So you cannot deny this fact. Presently, we are living in a digital era, and of course, these are the buzzwords. So whenever we are just turning around this world, we are just coming across these words inadvertently, like artificial intelligence, machine learning, deep learning, and data science. So these words are actually gaining a lot of momentum in this present era. So you know very well that since we are all academic people too, there are so many new programs are also evolving on these themes. So either it could be at the post graduation level or undergraduation level or diploma level, or it could be a certificate course, or if it is going to be a professional programs. So every now and then we are just witnessing new programs are being evolved based on these four buzzwords, and also they are related to these things. So actually, no, sometimes we may have a question. Yeah, what is the artificial intelligence? What is machine learning? And what is deep learning? And are the same? Or they are different? Or whether we can put up in a single word called AI or something like that. So every now and then, we have a little hesitant to go on with the exact meaning, or I could say the definition of what is all about these three things. And later we could just come back to the data science. As I said earlier, artificial intelligence, or either it could be a machine learning or deep learning, look at the year where it has been coined. So it is not just very recent in 2020 or 2021, nothing like that. So it actually few decades back itself, these things have been evolved by the researchers. But now only, maybe I can say that after nearly 50 years, around more than 50 years after only, now we are just moving at the back of artificial intelligence. We are telling that that is going to be the future of the world. Everything is going to be automated, and we are just going to witness a new kind of world, a new kind of job eras. So many things we are actually coming across it presently, because we always like to foresee, how the world will be there or how the nation will be there in the next 10 years or next 20 years. So they say that this is going to be the future, so everyone have to study this, everyone has to be well versed with the programming skills at least to some level. So many things. Even now also, no, you'll be able to come across most of the conferences are being conducted on these themes, and most of the research articles are being ebbed in these themes. So now, what is artificial intelligence? So it's very simple. So John McCarthy in the year 1956. So what he has actually said that, see, artificial intelligence. So we human being have the real intelligence, and we want to make the human, that is, make the human intelligence to be mimicked by the machine or the computers, or however we say that. So we want the performance of the human to be mimicked by the machines. So here, it is nothing but the technique or any technique they are telling that which enables the computer to mimic the human intelligence. Of course, they are using the logic or if then roles, or it could be a machine learning. So it could be anything of the kind. So artificial intelligence is something, it's a technique that making the computer or making the machines to mimic the human intelligence. In very simple terms, I'm telling, I'm not just going into very technical terms, because for every common person to understand, because we cannot say that these concepts are actually subjected only to the field of computer science or only the field of mathematics, something like that. It is being employed by every researcher belonging to every other field. Rather, it could be a business, rather, it could be biological sciences, rather, it could be a social work. Nowadays, social science researchers know they are using these buzzwords. They are using the techniques of machine learning. They are using the techniques of deep learning to explore the problems in the social aspect. So now they cannot own it. No field or no domain can own that. I could be used only by this. Maybe they may be the source of devising and designing, but when speaking about the applications, no, it is actually widespread to all the fields. No one can deny that actually. So now coming on to the machine learning. So what is machine learning then? When you say artificial intelligence is some technique, you are making a computer to mimic. Then what about the machine learning? So it is nothing but it makes. So how can you make the machine to mimic? You need certain programmings. You need certain algorithms. So that encompasses called the machine learning. Always we refer the machine learning algorithms. So something that you are going to make the machine learn using some algorithms. So that algorithms will be having a statistical, it can have a computer background. So it has some backgrounds. It has some logical and systematic backgrounds. So now this has been evolved by Arthur Samuel in the year 1959. So then what again is deep learning? See, deep learning, they are telling that that is actually a subset of machine learning. And of course, when you say machine learning, it is a little more comprehensive, it is more broader enough. But then you are taking a subset of the machine learning and you call it as a deep learning. And moreover, this is involving the neural networks. Now, this is actually a subset, a kind, and it is being emerging as a special domain of the neural networks. And this has been excavated by Rena Decker in the year 1986. So, just plain looking at the years of their invention, they are a bit old. They are earlier invented concepts, but now currently having a lot of implications, and it is expected to have a lot more implications in the coming days. Then, what is data science? See, data science is actually being coined by Peter Nahr, and I can say that it is little recent in comparison to the other three in 1974. So the data science, no, this is actually combining the math, statistics, programming, and all these encompasses. So when you are going to look at the data science, the most predominant word and dominant word is data. See, something you are going to do with the data. And always recently when people were started to work on various programming languages, various open software, open source, they simply give the reason. For example, when you are going to deal with your R, or when you're going to deal with your Python or something like that, they say that, see, when you are want to deal with the large data, so big data analytics, so you refer that big data analytics, so some data. So that particular data, you want to do a lot of analysis. You are going to again employ a lot and lot of algorithms, and again you have to derive these algorithms and their own implications everywhere with respect to the data, and that you actually call it as a very broader term. It's data science. And eventually we cannot deny the fact that whenever you go with a systematic, algorithmic, or logical way of handling things, definitely there will be an intervention of mathematics. So mathematics and statistics, and of course a few concepts of your linear algebra, so everything. When I say mathematics, and obviously it encompasses all the aspects. So all these things together, no, it is acting as a fundamental background or underlying principles based on which these things are being evolved. So this is a simple light on about your AI, ML, and DL, and of course DS. So all these acronyms we have to just get in our mind for years to come. So now, as I said earlier, that the most dominant one, I can now say that this data is actually ruling the world. So eventually, so whenever you are going to take a survey, or you have to make a particular analysis, or whenever you're going to address a problem, immediately you always speak with some data. So whatever the data, the first hand information you are getting, or maybe it could be a primary data or a secondary data. So now we could say that people are a lot more working with the data. So if people are being like working on with AIs, working on with MLs or DS, those people, generally they are actually dealing with the data. So only with those particular data, they can able to make a lot of inferences and so on with that. So I could say that, yeah, this is a simple throw of light. So what actually you are seeing is some platforms where we are always finding ourselves. So it may be a Google or Facebook or YouTube and the things. I think I have just left to WhatsApp because it is becoming a part and parcel of our life. No? And whatever we want to go and search, we now go on with the Google, and now Chat GPT is dominating, and that is also coming. It is with updated versions, and so we automatically keep on engaging ourselves in these platforms in search of certain things. You know very well about the Facebook or YouTube and Twitter. So you just imagine that how many data is being shared in your Facebook, in your YouTube. Just give a look at this slide. 1 hour of video uploaded every second, 400 million tweets per day, 10 million photos uploaded every hour, crossing 24 petabytes of data per day. So one peta is refers to 1,000 terabytes is there. So one terabyte is 1,000 gigabytes, so GBs. So you imagine and see 24 betabytes. Oh my god, it could be something, and somewhere the data size is going to be there, which is unimaginable. Actually, it goes beyond that. So every now and then, we are actually dealing with a lot of data. So now you know very well that in WhatsApp you'll be updating your status, you change your DP, and you give your lot of informations. So everything, whatever you are just giving, as an a photo, or it could be a text. Everything use accounts to a data there. So now we can really say that we are a data fight. So we can ourselves know, we ourselves provide lots and lots of data. The things, you know very well that the mobile phone that we are actually having, the Android, it senses, it knows our taste, it knows our preferences, it knows our choices, it knows our likes, it knows our dislikes, so it knows everything. So all, if you can have a review of it, what I have done and where you have visited. So every all those things, that's the data is being unintentionally collected by all the sources of that. So now, what are the data types? What is data actually, and what are the data types? So we have just discussed about the data. Now what are the data types? See, data types are nothing but it could be a text, it could be numbers, it could be videos, it could be graphs, it could be tables, and it could be images. So these are the different types of the data, and I think we are familiar with all those things. We text, we deal with numbers, we are very very good at uploading the videos and the graphing, presenting the data in a very organized form, then again in the tables and lots of images. So we are very much familiar with the data types. Okay, now coming to a very little way, what is machine learning? See, that picture itself says, so machine learning is in simple terms that it is nothing but making the machine to learn. And also, if you just put in a very technical term, it is broadly defined as some computational methods. And you want to enhance the performance and you want to make accurate predictions. So, this is all about machine learning. When I say machine learning, what should strike our mind? Of course, it's the computational methods. And why do we use machine learning? To improve the performance, to make the accurate predictions. So, that is actually the machine learning. So, as I said earlier, in very simple terms, I want to make the machine to learn. Okay, how can I make the machine to learn? That is more important. See now, look at the situation that we are going to discuss now. If I want to make a computer to learn about a tree, so simple. If you're going to make a child to learn about a tree, what will you do? So definitely you will take the child to your garden, or you will take somewhere the roadsides or the places where you can find the trees and show that says, look, this is a tree. And you will say, look, the tree with you have a very big trunk, it has a lot of branches, look at it, has a lot of leaves, it has fruits, it has flowers. Like that, you will be giving a narration, a description to the child. Or sometimes you can show the pictures of different trees and say that even a coconut tree doesn't have any branches, but still we call it a tree. But generally, when you draw a tree, you will draw a tree with the branches. Suppose if I'm asking you, you just kindly draw a tree, and what you will do automatically, we start with the main trunk, and then it branches out, then we draw some leaves. So of course we do that, because this is actually a mind. No, whenever we say that it's a tree, we have an image of a tree. So now that image, it has to be fed into the system. So whenever I'm just uploading a picture of a tree, it should say that yes, it is a tree. If I upload a picture of a man, it should say it's not a tree. So that's how I want to make the machine learn. So this is a simple task. If I want to make a child to learn, as I said earlier, it is so simple. I can describe about the tree. I can show the images. Even I can make them to touch. I can make them to have a tangible effect and experience the feel. Yes, everything I can do that. But for machine, do you think that it's possible? So we cannot teach the machine. So you can train. So that's what they are telling that. How can you do that? So there are generally two approaches are there. So procedural approach. So what do you mean by the procedural approach? So it is nothing but you always give a narration or descriptions or all those things you just fed into your system and you go on with that. So if you're going to give an image of that, a description, all those things you're going to give a that. Or you can upload a lots and lots of images and you could tell that this is how the programming. So all that you can make. So this is a kind of procedural approach. So what about the data-driven approach? So data-driven approaches, you are going to convert the features of a tree into a data form. So only then you will be able to make that particular system to train itself with the knowledge of identifying a picture of a tree as a tree and picture of not a tree is not a tree. So this is actually the data driven. So procedural is you can feed lot and loads of images to the system and you can say that if this is like that, you can say that it's going to be a tree. So that you can do it. But you imagine and see how many species of trees are there. I mean a tree at different stages. Maybe the tree in the season of autumn has no leaves, but directly you will give a description that a tree must have leaves. So a tree without leaves cannot be said that it's not a tree. But of course, it is a tree, but it is not having leaves. But even then, also it's a tree. So look how much of complexities we are making in a procedural approach. But then in a data-driven approach, you are going to convert the features and you're going to give them input in forms of some data, and then you are going to train the machine. So this is the difference between the procedural approach and the data driven approach. So we are going to follow the data driven approach. Then you may ask also the question, yeah, what is the need to make the machine to learn? Why you want to make the machines to learn? So you know very well that for the task simplification, to handle the complex data sets, and to accomplish the very difficult task in a very short span of time, you want the machines to learn. And you want to make them to learn at the core so that it gives us you the expected results. So I'll just give you some instances. See, have you ever wondered that how could the mail sent by one person falls into different categories? So when you're going to open the Gmail, the most commonly used the mail app, and you are getting a mail in your mailbox. So whenever in your inbox you're having a mail, automatically it fits into three of the categories. Either it could be a primary, a promotion, or social. So how it's happening? So if you just take a minute of time and look into the messages that you have received in the promotions, it will be more related to some advertisements, some offers, or something like that. So you are just going to promote certain things. It could be anything. Either it could be a product or it could be a service. But then if you're just going for the social, all your social media related messages, either it could be a Twitters or it could be a Facebooks, or all your updates have been falling into that. So now, sometimes people will be saying that I have not received the mail. Then they'll be telling that kindly check your spam. Maybe it can be fallen this mail. I don't know why. How could it could happen that mail being sent by the person this doesn't falling into the category of primary, but it again goes and sets in your spam. So it's happening. So have you ever wondered with that? And all the more, your product recommendation. Sometimes, no, it actually does with the sentimental analysis. You know very well that whenever we are just going to buy a product in online, you'll be always looking into the ratings, about the reviews of how the product or how the service is going to be there, and based on that, you start doing many things. So it is having a product recommendation based on the earlier comments. It does it. The diagnosis of disease. So you know very well that when there are biological techniques of identifying the present disease, what is the need for your machine learning? What is the need for the interference of the ML and diagnosis of diseases? As you know very well that the biological test maybe is time consuming, so they are people are preferring the biologist or the medical persons that are, the researchers are actually trying on with the hybrid way of diagnosing the things, so instantly. So you know very well that there are two labs are there. You go with your wet lab, you go with your dry lab. So more doing on with your wet lab, that is your actual experimenting on all these things. Nowadays people have started to go on with your dry labs. It is similar to like how we do the simulation process, no? So eventually you develop a prototype and you want to test on with that. But here in a similar way, you just go on with your dry labs. So in dry labs, when you go with the biotechnology people, they are doing a lot of things in that. And so now in your diagnosis of diseases, so in that also ML is having a lot more of applications. And then forecasting. So you want to predict if today is this status, what will be the tomorrow status? What will be day after tomorrow status? What will be your status after a week, after a month, after a year? I just want to make a lot of forecasts and predictions. So this is highly used in business. Say in business now it is an unpredictable and unprecedented or uncertain situation will be existing. But generally, certain things, no, you have to be very much well aware of what could be the things in the near coming days, so that you can able to prepare yourself to face the business related problems. So this were the reasons that why you want to make the machines to learn. Now, coming to the types of ML. So there are different types of ML are there. So one is actually the supervised learning, unsupervised learning, semi-supervised learning, reinforced learning, and the deep learning. So as I said earlier, it is actually a subset of machine learning is deep learning, and at certain instances, they are actually categorizing deep learning as a different type of a machine learning. So these are the way that the researchers have been evolving the particular deep learning concept based on the extensive implications in the real life. But it has the grounds, it has a touch of the machine learning. So there is no doubt in that. So we'll have a quick run of each of the things. So, what is actually the supervised learning? The supervised learning, no, it's a kind of a machine learning. The way name itself, the way the name of itself, it is supervised. So, actually, you will be having an input and output pairs. For example, the very best example I could say that the data that you are going to use for solving a regression problem. So what is basically regression? So it's so simple. See, regression establish a relation between the dependent as well as the independent variables. That's very important. And with which the regression equation, you can able to make predictions. You can able to forecast for one particular instant of your input. So that is actually the basic idea of regression. So you know very well that you have X, you have Y. So you have X column, you have Y column. So what is X and what is your Y? So all those things are being given that. So what will be your input and what will be your output? So your input and output pairs are being known. And here in your machine learning, always you will be dealing with two things. One is actually the features. For example, if I want to identify one particular object, I identify the object with respect to the features. If I say tree, even I can say that the leaf count, I can say about the branches number, and I can go over the size of the trunk. So that is very important. So even in a plant, you will be having all those things, but you cannot call a plant as a tree. Even in a plant, you will be having a slide, branches will be there, leaves will be there, flowers will be there, fruits will be there, and everything will be there. But you cannot say that it is actually a tree, because for a tree, you will have an imagination about larger in size and all those things. So, what type of features you want to pick it up so that you can describe the particular object in the correct way. So, I'll give a very simple example. If I want to identify a fruit to be a raw or ripe, so I can have two features. One is a color, but the color I can identify whether a fruit is actually raw or ripe. And then with the weight, the raw fruit weight and the ripe fruit weight, definitely there will be differences. So with that, I can able to identify whether a fruit is actually raw or ripe. So these are called as the features. The features are very important because that is going to play a significant role. And what are the labels? So based on the input features, I could give as an output whether it is a raw, whether it is a ripe. So I can able to give the output. So this is called your supervised. You will have both input and you will be having the output. So you can make use in classifications. Okay, I can able to say that if a particular mail is containing these words, you put it as spam. So there are so many mails. If you're looking into your mailbox, most of the mails with the dealing of money. So you have won this lottery, you have been sanctioned with this amount, you are credited, and all those things. Such mails it will be always putting in spam. And if it is unknown mails and it is having some threat, those mails which has been received by you, it will be also in the spam folder. So this is actually what we called as a classification. And then you go on with the regression. As I said earlier, you are going to focus or you are going to predict the future. So this is a very simple note on the supervised learning. And coming to the unsupervised, so it is simply the reverse of it. No, maybe you go with an opposite of it, I should say that. When you say you have both input and output as supervised, then in unsupervised, you'll be having only the input, you don't have the labels. You have only the features. And where it can be used? So it can be used in clustering. So you'll be able to group. So now it's very simple that maybe if you are having some 20 persons with you, so you can clusters them, you can group them based on the gender, based on their age, based on the gender as well as the age. So I can say that maybe if I'm getting the age span between 20 to 30 or 20 to 40 people, I'm just going to have the age span. So I can categorize them with the 20 to 40. So I can say 20 to 30, 30 to 40, two groups I can make. In that I can able to make the female as well as the male category. So I can able to give lot of clusters. But the gender and the age, so these two are the features. So based on that, I can able to give a clustering of that. And maybe you just imagine that if you are keep on increasing your features, then definitely it is not that easy for us to give a precise number of clusters. See, the clustering is you have to actually make the number of clusters as less as possible in order to give us actually a very good inferences at the end of the things. So that we called as a dimensional reduction. So dimensional reduction is basically the understanding is you want to lessen or you want to reduce the number of the features. So you have so many techniques for that. Okay, the most commonly used is the principal component analysis. And when you go with the clustering, the customer segmentations, you know very well that if people are launching a product, the business people, then definitely they always go for the segmentations. They go for the urban or rural background, the age, the working or professional, so many things they are going to take into it when they are going to launch a particular product. So this is about unsupervised learning. So what about the semi-supervised learning? See, semi-supervised, as the word itself goes, it is partially supervised and partially it is not supervised. So it is going to be unsupervised. So from some data sets, you will be having the supervised data, and other things, no, you will not be having a supervised. It will be unsupervised. So it takes place. It will be taking place in some things, because for some data sets, you know what will be the label. For some data sets, you cannot give what is the label that. So that is actually fall into this particular category. So I could give a very best example with that. So here we are giving the news article categorization. See, if I'm going to read one particular news, you will be able to identify to which domain it actually belongs to which category it belongs to. Either it's a politics, either it's a sports, or either it's a wildlife, either it's going to be a cinema, either it's going to be entertainment, or it's going to be a business. But some news articles, it would be actually and encompassing so many aspects. It could be a politics and it could be a business also. It could be entertainment and it could be a business also. It could be a sports and it could be entertainment. So many other things will be added on to it. It could be an education, at the same time it could be again related to business. Okay, about the economy could be there. So many related aspects are there. So that time, no, we'll not be able to give one single label whether it is this or that. So at that particular time, you'll be having a lot of features. So what will be the features here? The features will be the words that we are actually using. What are the words we are using with respect to the politics or respect to the entertainment or sports or whatever it might be. So the words that are we using, and the number of occurrences of the words also matters. Just because the word party comes, I cannot say it belongs to politics. Just because the word it is coming sanctuary, I cannot say it's a wildlife. So I cannot just give a decision on that. So the occurrences of the words pertinent to each of the field also plays a very important role. So what I like to say here is look at the inputs, look at the differences of features of what we are giving as inputs. So coming to the next one, see, look at this one. This is actually the reinforcement learning. What we teachers are actually doing it in our real time. So whenever we want a particular behavior, we always reinforce this by giving the positive remarks. Whenever we don't want a behavior to be exhibited, we always give a negative reinforcement and to delineate that particular action. We don't want the action to occur. So we always give a negative kind of reinforcement for the student's behavior. Similarly, look at the thing is happening the same way. You always have an agent with that. If that's particularly moving towards a right way, you give a reward, and that is going to signal that yes, it is going in a right way. Otherwise, you penalize it for its responses and for its actions not take place. So it is going to be a sequence of actions. So if you're going to do the action A, if you're getting a reward, then automatically it goes repeated with the other related actions of it. If you feel that you are penalizing it by giving a negative remarks and negative score for it, then automatically it stops doing the particular activity, and again it diverts from that action and move on with that. See, there are so many algorithms out there. You go with the Q learning, you have deep Q learning, so you have so many other new algorithms are being developed in reinforcement learning. So basically, it is like game playing, about playing in a computer games. So all these things are having a grounds of your reinforcement learning. And then coming to the core important part of it, so it is the deep learning. So as I said earlier, see, deep learning is actually a subset of machine learning. There is no doubt with that, where your artificial neural networks are going to have many layers. Actually, the artificial neural networks is the layered structures, and it will be having a lot more of layers, a multi-layered artificial neural network. You just call it as the deep learning. So that is going to play a vital role. Sometimes you call it as deep networks. So these networks are getting some additional names. So basically, where they are used and why are they used? To go with the image recognition, to identify the objects, to go with the natural language processing. As I said earlier in your sentiment analysis, based on the remarks, based on the stars, based on your scores, what you're giving your product, that product will be reviewed and that will be taken as an input. That feedback will be collected, and again it will be taken as an input, and again people will be working on it. Sentiment analysis again is a separate concept that being highly used basically in the business related aspects. The sentiment analysis is being used most prominently. This being used there. So this is actually the deep learning. So now we have come to the point where your ANN starts its origin. Okay, so before stepping into your ANN, I like to just give you the basic steps involved in machine learning. See, it's very simple. The machine learning can be of any type. The machine learning algorithm can be belonging to any type. But generally, what are the steps involved in machine learning? So it's very simple. As I said earlier, you want to make the machines to learn something. How can you make the machines to learn something? You want to train them. So how can you train them? You have to train them with the data. So simple. So the very first important thing is the collection of the data. So what is actually your problem? What are the features that you want to take into your account? If I want to make my machine to differentiate the fruit between raw and ripe, if I want to make a machine to predict, if I want to make a machine to diagnose, what is your problem is actually? So you want to identify the problem correctly. So once you identify the problem, then you want to be very much specific in your selection of the input features. If you are going to go for a supervised, you provide the labels. If you don't wish to go for a supervised, you want an unsupervised, you can just go on with the only the input features. Or if it is going to be a reinforcement, depending on that, you can take the data. Okay, so this lecture is going to be more on your supervised, and it may be through light now on some unsupervised also. So data pre-processing. So whenever you are collecting the data has to be in the form of an apt one. So there must be no missing terms, there must be no outliers, and of course it has to be normalized. Some data could be a categorical one, so you want to convert everything into a numerical representations. Sometimes you may, sometimes you may not. So it depending on that. But for the easy things, it's better you convert everything as a numerical input so that it will be able to understand. And most probably the numerical input is better. And of course, that's what the machine learning is also is so comfortable with that. The next one is you split the data. So it is 70 is to 30 percentage. Most probably the people are using it. So 70% of the data that you have collected it, that you have processed it, it will be used for training, and 30% of your data will be used for testing it. So you are going to use the data allocated for testing based on the training efficacy of the 70% of the data that you have subjected for training. So this is actually called as the splitting data. That is the division of the data. So what do you mean by that is you already you are trained certain data. So if you are going to test the trained with the new data sets, it will be giving you certain results, and you can measure the accuracy of the algorithm or the efficacy of the training that you have been given. So now coming on to that, then you will be choosing a model. So what is that choosing a model is? So you want to choose an correct algorithm. As I said earlier, which type of machine learning you are going to do that, you just have an idea on that. There are so many algorithms that can be used under each of the types. So you want to choose a correct and appropriate machine learning algorithm. What is basically your problem, suiting to the needs. So now you train the model. You train the model, and then you test with the model, and then you start evaluating. You check whether your accuracy, your precision, and your recall and all those things are true or not. I'll be just telling you about things. So I could put a single term called accuracy, whether it's accurate, whether it is efficient in giving you the right predictions or not. So all those things. So if it is not, then fine tune it. Then again you repeat this process until your accuracy is up to your desired level, up to your mark level. And all the more, what is the basic idea is you have to supply a large number of data sets. Only with the big data analytics, a large data sets, this kind of training works. And also, with simple and less number of data sets that you are providing, and then you are expecting some desired results, it may not work. It may not up to the things, and it cannot be applied universally. It may be true for that particular data set, whether you can generalize it. So one of the other important hurdles of machine learning is again the data. If the data is randomized, if the data is not correct and it is not precise, and if you are giving an accuracy or something, it may not be applied to the actual life. It may not be suitable for application to the real life instance. So that's also one of the big setback when you deal with the data. So the data collecting and data processing and choosing your type and algorithm plays a very crucial role in making it universally applied to the real life instance. So now coming to the part of artificial neural network. See, it's very simple. I could say that it is a bio-inspired algorithm. So look at that. No, we human being are having a neural system, and that neural system is being mimicked. So the reason why I choose artificial, it is more closely related to us. So however we are doing our thinking process, is similarly, no, we are making the machine do the same way. See, wherein McCulloch and Walter Peters in the year 1943. See, 1943, somewhere before our independence, I should know. And now we are an independent and we are celebrating the 75th and Maha. So much we are celebrating, and now we are talking about the applications of ANN and decision making. So look at how long it takes for a concept to reach the entire universe to make it into an application aspect. So this is what I was really wondering that. So the concepts are not very new to the theoretical aspect, but putting into practice, so now it is blooming. So we can say that the artificial neural networks exactly works like our neural system. So it's very simple. I should just explain you. So as I said earlier, they are actually inspired by the way the biological neural networks are working in the human brain. You know very well that the control unit of a human being is the nervous system. So the central nervous system, no, actually the neurons, our neural system is actually a composition of neurons. They are the building blocks of the nervous system. So a neuron is actually, they are basically responsible for receiving, for processing, and for transmitting your responses. It receives a stimulus, it processes, it again responds, it gives an output. Of course, since it's a biological process, you know very well that all are taking place, electrical impulses, and you have the chemical signals and so on. So that is actually the functioning of our neurons. So what I thought is, so it is a bio-inspired neural network. No, your ANN is a bio-inspired network. It's an ML like that. Now, generally, what is happening in our brain? We have to know it because it is our human system, or your nervous system is there. What is actually happening here? So simple, no? Say now you are listening to what I'm just telling. So something you are receiving. So this is actually the brain receives a lot of things. The neuron, as I said, it is a functional unit. You always get your input. So that input is being received by a particular part called dendrites. Okay, and then what happens is, it is not only one signal it is being received. It is keep on receiving the signals, and as it is receiving the signals, it is getting integrated. Then integrated in the sense that again what happens is, it just finds the sum of all these particular signals, and then it is going to generate one electrical impulse called action potential. Then this is actually passing on to another one part called axon. So where some changes or some processing is also been taking place. Then finally it is being transmitted. So there it is happening a neurotransmitter. So neurons is actually comprising of all those things. They receive, it's a dendrite. Then actually they collect all those things. They move on to an axon. They process it. Then they are actually transmitting it in synapses. Okay, fine. This is what is actually happening. It again, it passing on to the other neurons. So you know very well that the learning also takes place in a similar way. And one particular point I should just mention. Signals received by the dendrites, they integrate. If the integrated signals that pass a certain, so it has to go on with a certain threshold. See, maybe in your real life itself, no, or in your daily occurrences of thing, we used to say that I heard, but I couldn't remember that. It means that the input is not receiving to the threshold level for us to sum up and pass on to that. It simply you have just received, but you're not able to process it, and you're not able to give us an output. And sometimes you will always say that I know it is something, but I'm not able to tell it. So look at that, it is a process actually incomplete one. So you used to say that please don't say something, I'm getting disturbed. I feel that I'm forgetting everything. I forgot everything what happened on that day. So all these things are there. So this is actually the intervention of the external one. So this is also it's taking place in our real neural system. So this is what actually the biological neural system is there. Now I like to just compare with what's happening in the artificial neural network. So this is a pakka example to show how the neural system of a human brain is mimicked into an algorithmic way. See, actually, no, you have different layers of it. Like you have an input layer, you have a processing layer, you have an output layer. So these are the three core layers. So you call it as the neurons. So x1, x2, all are inputs. And now look that it is integrated, the sum. Then as you said, it is passing on to the axon, some processing is taking place. So some activation function is there. Then finally the neurotransmitter. So it is transmitting. So it is an output, it is being coming there. So look how beautifully the things happening in our nervous system. It is being mimicked in this ANN process. And this is a very simple ANN process. You receive some input, some processing is taking place, and you are getting the output. So that processing, whether it is a single stage processing, whether it is a double stage processing, whether it is several stages of processing. So when I say stages, I like to say put in a word called layer, whether it is a multi-layer or whether it's going to be a single layer. So look at that, how this is getting the complexity. So whenever the number of layers are being increased or multiplied, then you can speak a lot on your accuracy. All those things to go on with your accuracy. So now I can just throw light on how your artificial neural networks are actually functioning with that. As I said earlier, you have an input layer. So your input layer, it receives in the form of the features there. All your input is a feature. So if you are going to have three features, that is going to be that. Then how are they related with the what weights? So you have some weight assigning to your each of the inputs, because they are the features, they are going to play a vital role, so they'll be having some initial inputs. Now these weights, they are actually connected to the other layers. So in what way they are connected, how they are connected, so the strength of the connection is being estimated, or it is being measured using that particular weight. And then, as I said earlier, it is an activation function. You are in need of activation function. So what type of function it would be there? Yes. So the function is basically a non-linear function. It's not a linear function. There could be ebbs and flows will be there. It could be have a lot of transitions will be there. So you cannot always expect a linear kind of functions of that. Most probably it is going to be a non-linear. Then you will be having some hidden layers. You will be having the output layer, and definitely you will be having some expected output. But actually, what output you are getting it? So that will be the error. So the efficiency or the accuracy of this particular algorithm lies in the quantity of the error. So how much of error is there, whether it is so much or whether it is limited, and all these things. Then coming on to the back propagation. So this is the algorithm which rules the AMU. I should say that. Basically, this is the backbone of your AMU. The algorithm that is most commonly used is this back propagation algorithm, and it is an iterative process. And we'll be throwing light on the back propagation algorithm too. Okay, now what are the different types of neural network are there? So there is actually a feed forward neural networks are there. So what is a feed forward? See, so simple. No? You always move in a forward way from input to hidden and the output. Look at the flow of the informations. It is from input to output. You call that way is a feed forward. And suppose in the case if you have feedback, it has the other way also. It can go in two directions, from your output to also the input. So, but feed forward is most prominently used network. And what about the recurrent neural networks? See, recurrent, this kind of neural networks are being applied to a sequential type of data, especially with respect to time series. So there only will be falling on with sequential data. So whenever you go over the time series, there you'll be having recurrent. So you go with the feedback loops also, because there you have a space for the iterative. So the feed forward and recurrent, they are actually most commonly used. And now convolution neural networks. So convolution neural networks are actually used if your data sets are quite images. As we said earlier, that image recognition will be there, and all those image identifications. So many things will be there. So convolution neural networks. So if you want to make a diagnosis or identification using your data sets to be images, completely you have images. So now we have been working with one particular data set for cancer. So here you had 500 images. So that time I cannot be translating each of the image to numbers and doing all this. That's something a very tedious one. But rather you can use CNN. So CNN is having a lot of good packages with there in your R and Python, and where you can explore the CNN, and that images have been used as their inputs. Then another one kind of network is actually generative adversarial network. See, they have two networks. One is a generator and another one is a discriminator. So generative in the sense it creates a new data samples with a kind of network, and then the discriminator is able to find between whether it is a real or fake. So this is actually depending on the nature of the data sets. One is image, you go with CNN. If it is going to be a generative, if it is going to be a random one, you can do this one. If it is going to be a time series or sequential data, you go with the recurrent. If it is going to be other data sets, you can go on with the feed forward. So based on the nature of the data, you can choose any of the kinds of the neural networks. Now, coming to the activation function. So, as I said earlier, what are the common activation functions I've been using? Sigmoid function is basically used. Generally, sigmoid is most commonly used by default. And then you go with the hyperbolic, then rectified linear unit. So you know very well about the sigmoid activation function. So I don't want to just go more mathematically because it is a function, has its own range, it has own properties. So again, hyperbolic, the function is being defined like in terms of your exponential, and you go with the rectified. So this is actually a standard function. It is defined. Maybe you go with how you go with certain functions which is obviously defined. No? So these are some sigmoid hyperbolic tangents. So they are commonly used. So why are they highly preferred? That is very important. Why are they preferred? So why sigmoid is most prominently, no, and it is again default it is pale prepared. They always go with the sigmoid activation function. So why? Because look at the range. It falls in 0 to 1. It's very simple to make decisions. And sometimes when you go with a -1 to 1. So if that is going to be your range, okay, fine. But generally, we never prefer we go with a -1. Or maybe you go with the most negative, the minus or positive to that one, and all these things. Then look at the range 0 to again it is more. It is going to be. I could say that the large number of values you can go on with a 0 to infinity. So you go on with the 0 to 1 at the range. So coming here as the layers. So layers we can go on with the input layers. So the input layers you will be having, and you will be having the hidden layers, and then you will be having your output layers also. And sometimes you will be having the bias also. So what is that bias in the sense? See here, as I said earlier, no, maybe the external disturbances that what is being taking place. So to control it, we always use one particular concept called bias. It is actually basically used on need based only. So that's fine. You have it as the bias. So all those things, no, when you talk about the layers, you won't go on with that. Now, back propagation algorithm is a very popular algorithm. It is being used, and nowadays, no, they are also using some stochastic gradient descent algorithm. So people are also excavating on that. They are developing some hybrid algorithms. They are developing a more number of hybrid algorithms based on the back propagation. So it will be derived from the back propagation algorithms only. So now coming into the overall structure of your neural networks. So if you just look, you will be having a better understanding. There is no any restriction in the hidden layers. But look at the output layer, you have so many outputs. You not always have only one output. You can have so many outputs. If it is going to be a classification, everything will not be fall into only one classifier. No? You will be having so many classifiers. So many classifications also will be there. So you go with your input, you go with your neurons are there, hidden layers are there. You have two hidden layers, you have one hidden layer, and you have only one output layer with so many output neurons are there. So look at that. Your layers are actually fed with a very good of neurons. So this is what a simple overall structure with that. Now let me just give you a very good simple example of your back propagation. So this is a very simple example of your back propagation. I like to throw a light on this. See, you have two inputs, you have a weight with that, and then look at your hidden layers. You have your connection with this and output layer. Now what I want to find is your Y3 and Y4. Y5 is actually the actual, it is 0.5. I can calculate this forward pass 1. What are the layers? I can say that for the H3, what are the input neurons are connected? I can make on with that. So I can have a sum of it. I can apply the activation function. I can get the answers. So this is very simple. Then I can repeat the same procedure for the output. But when I come to the output, look at this, I got 0.69, but my target is 0.5. Look at the errors. Now I'm going to update the weights. So what does this AN does it? It is actually updating the weights by using this set of formula. So since because of the time constraint, I'll just give a light note on it. It will be the learning rate because this is an algorithm approach. They have their own nomenclatures. So they have their own parameters, and eta is actually a parameter. And depending on that, you have a very good explanation for this actually.
There are so many books are available and sources are there where you can able to understand about your back propagation. So I'm just go with the backward pass. So I want to calculate and update the weights of my Delphi, and if it is going to be hidden, if it is going to be output, I can make it. So in this way, I can apply the back propagation algorithm and I can update the weights. And now whether this is going to yield me a less error. So look at this one. Now the error, there is a change from minus 0.19. So my errors are being nearing to less. So I want to just make it up at least nearing to 0.00 something, so that I can say the error is negligible and my result is fine. So there are so many applications of neural networks out there in decision making. You want to have with the predictive, you go want to go with your fraud reduction, diagnosis, your customer service, your prediction, assessments, and so on. And what is the basically difference between your neural network and traditional decision making? See, traditional always having a human intervention. Neural networks always deals with the data.
So that is very very important with that. And also it is highly adaptable. You can able to make a lot of changes in that. You can able to change your input features, you can change your weights and all those things, and you can able to give a lot more of predictions and accuracy in that.
So now, how can you evaluate the effectiveness of neural networks? So look at this one. Actually, you'll be calling this as confusion matrix. We have the predicted and actual, the true positive. It's a false positive, false negative, and true negative. So true positive and true negative is precise. False positive and false negative has to be minimized. So look at the efficacy, your sensitivity, specificity, and accuracy. And also you have the precision, recall, and F1 scores. All these parameters will be able to measure the efficacy of this particular neural networks. And now I'd like to just to go on with a simple thing. I hope the things are visible to you. See, this is actually an out of my interest. I like to just give you in your. This is actually the R platform. We need not worry about the R and all those things. What is the main problem is this is actually some sample data is there. So what is the sample data is? I want to make the diagnosis. The heart disease is there or not? Look at the data. I am taking age, the sex, the chest pain type, the resting blood pressure level, the serum cholesterol level, and I want to diagnose whether the disease is there or not. So I have the code to execute in R. You can execute in Python. You can even do it well in MATLAB. So whatever the platforms are there, we have separate packages. But I find very comfortable with R. So I just go on with this a particular code I'm just feeding here, and look at this. I'm having a sample to be 500. So this is for applicability. This is I'm getting a data set of it. So library mass is actually the place where you can get the data sets of this kind. So now I'm splitting it. Zero point 0.7 to I'm having 70% of training. Remaining is actually the testing. Look at that. My target is actually whether the disease is there or not. Very simple. So age, I have 6, depending on your gender, and then you go with your chest pain and all the input I'm just giving. So the train data, I want the header rate to be 1. You can give it as 2, you can give it as 3, depending on your necessity. Then I make the predictions, then the predictive classes. So 3 classes I'm giving you. Okay. So if it is 0.5, 1, and 0, some measures are there. So I'm just going to go on with that. So I have plot the model and look at the accuracy. It's just a 0.64. So I can now increase the accuracy by giving lot more of again the data. I can even include the other layers. I can extend it. So I can go on with more training data sets. I can give. So 80-20 also I can give it. So I can run on with that. So this is the way that I can able to do it. Now I can able to identify whether the disease is there or not. Then coming to the another problem here. Now this is nothing but identifying the break failures. See in machines, no, in actually you go with the business environment and the production sectors, they'll be very cautious with the machine maintenance. It's very important. So you can able to identify the fraudulent and even the failure predictions, all those things. So now look at the features. I'm just giving you 3 features are there and labels. If 1, 2, 3 is there, look at that. It is 0. There is no failure. 2, 3, 4, yeah, it is failure. So like that, I'm just giving. So the features can be 3 features. I'm just taking input. So I'm having the bind of all these 3 things. Then I'm giving 1 layer. So I'm able to predict. It is giving me just 1.12. But look at this. With this data set, I'm getting 1 point. So I have to again retrain it so that I could follow the values of other 0 or 1. So coming on to the another data set, So this is a very big data set is there. So this is more on the predictions on what? It is actually the business. The price is over that. So look at the data sets. I'm going to have some 1 is to 100. It's a randomized one. I'm just going to take the sample here. The price, the data I'm having. So I'm just having the particular code. So I'm able to get. So this is a summary of the results I'm getting it. And look at here. I'm able to make the predictions. I'm going to give the new dates as 101 is 200. So first 100 days of data I've fit. For the next 10 days I want to make it. So look at the result I'm getting, the prediction result. So look at this. I have two hidden layers I'll be having here. So I'll be giving the input as 3 comma 2. So in the first layer I'll be having 3 neurons, and second layer I'll be having 2 things. So look at that, I'm having C of 3 comma 2 is there. So this is a way that I could able to make a medical diagnosis. Then I can go on with the failure detection, the stock prediction. I can make it, and this is a very real life. The project that we have really worked on with that. So in diagnosing a masses disease in dairy cattle. So you know very well that the disease diagnosis is a very big problem here. So this is a contagious disease. So actually our college is located in such a rural background. So here they predominantly practice the occupations of the livestock. So basically for their livelihood, no, they go on with this occupation. So this is a kind of mastitis diseases. You will be saying the udder, it is being a disease associated with udder, so will not be able to abnormal from it, and it is a contagious one. You just remember that, imagine a farm, and if one particular cow is being getting a this disease, and automatically spreads on to all those things. So it's a very big problem. So now biological testings are there, but then you've got a lot of hybrid testings. You can give the input and you can have just a prediction of it, whether it is there or not. Then you can go on for further medical treatment. Now, what are the different types of algorithms we have used? And we used the gradient descent algorithm, resilient propagation, conjugate gradient, Poisson algorithms, Levenberg. These are the new algorithms. They are just developing it, the researchers. So they are able to find a very better algorithm that could yield a good result. So these are some common algorithms we tried with that, and look at all our input features. So look at, we had nearly 9 input features. Look at the type and the domain values. What are the values you take? Maximum all on input. All our numerical inputs will be given. And this is a flowchart of your ANN. And look at this one. So we subjected 70% of training and 30% of testing. And this is a network that we have got. This is the elementary one. Then we started working on with so many things with the different accuracies. So I just like to say one particular point. Artificial networks are actually gaining lots and lots of significance in the applications of real life. So it is better that when we have to learn more on its application aspects, and we can also apply this particular ANN algorithm in the real life, mainly for decision making. So decision making in the sense we go with the predictions, forecasting, classifications, and many other. So we can excellently apply this ANN algorithms, and manual we cannot be doing it. So we need the interference of the programming languages. So open sources are ample available for us, so we can make the better use of it, so as to make our research suiting to the needs of the present way. So at the end, I like to just thank the Gerizim Academy for giving me a wonderful opportunity to share my knowledge, what I have learned. Actually, myself being from the mathematics background, so I'm not that much well versed in all those computer aspects or algorithm aspects, but out of my interest, we just worked on with this artificial neural networks and keep on working with that with other extended features also. So once again, I thank the Gerizim Academy for giving me an opportunity, and wishing everyone all the very best for your research works.
Thank you, ma'am. Thank you so much. Thank you for your wonderful presentation. Now, participants, do you have any queries, doubts you can ask, or you can post in the chat box also? Ma'am,
Yes.
actually, Satyapriya, she asked one question, ma'am. Uh, Actually, her research domain is neural network applications. She's asking, where could we choose the data and how? Could you please tell me, ma'am, like that?
Yes, ma'am. I can just give you my point is there are two things out there. See, if you are working on new algorithms, and if you want to test the efficacy of new algorithms, then there are large number of data sets that are actually available. There are so many packages out there. For example, I showed you the mass. and then you'll have ML bench. So many packages are there where you can derive the data, where you can get the data. Already the data is available. There are so many repositories are there. You can take the data. But if you want to actually apply to a real thing, then you have to collect the data. So you know very well about the general steps how you can collect the data. So either it could be a primary data, it could be a secondary, and all those things you can start collecting the data. So I think these two things are there when respect to the data collection, and when you come down with the data. And